Hey guys, we are back with another question from September 2020 exam, and the question is given a RLC circuit in series. Find current, power factor and power consumed. Okay, so where is current? Current is here, I bar. Okay, and what is given to us? We know V bar is 100 at 0 degrees, and this is F, frequency 50 Hertz. This is the values of R, L and C, and we need to find current, that is I bar. Okay, power factor PF is cos phi. Okay, and power consumed P is VI cos phi. Okay, so how do we do this? First let us find current I. So current I is current I bar is equal to V bar by Z bar. Ohm's law holds true even in the case of single phase AC current, current and voltage. Okay, so I is equal to V by R. So this is a resistance. In case of DC we will call it resistance. In case of AC we will call it impedance. Okay, so what is Z? Z bar is impedance. So how do you find impedance? Impedance is Z bar is R plus J XL minus XC. Okay, so impedance Z bar is a complex number. All of these are complex numbers. I bar, V bar and Z bar are complex numbers. Okay, we will represent them either like magnitude with angle or in this is polar form and this is rectangular form. A plus JB. Okay. So we know we already know R. We need to find XL and XC. Okay, so what are XL and XC? XL is inductive reactance. So that is omega L. So what is omega? Omega is 2 pi f L. Okay, so that is 2 into pi is 3.1415 into f is 50 into L is 16 milli. 16 milli is 0.016 or 16 into 10 power minus 3. So if you substitute this in calculator, what you will get? XL is 5.0264 ohms. So XL is 5.0264 ohms. All of the impedance values are in ohms. Okay, and similarly XC is 1 by omega C. Okay, so what is we know C, omega is 1 by omega is 2 pi, so that is 1 by 2 pi f C. Okay, that is 1 by 2 into 3.1415 into 50 into capacitance is 150 microfarad. So that is 150 micro is 150 into 10 power minus 6. If you substitute this in calculator, we will get XC is equal to 21.22 ohms. 21.22 ohms. Okay. Now that we found out XL and XC and we already know R is 10, what is Z bar? Z bar is R is 10 plus J into XL minus XC. XL minus XC will give us 5.026 minus 21.22 will give us minus 16.1936 ohms. Okay, so this Z bar is in rectangular form, A plus JB form. If you want to divide, both should be in polar form. V is already in polar form, 100 at 0 degrees. We need to convert this Z bar into polar form. So what will that be? You can use calculator directly. Z bar in polar form will be 19.032 at an angle of minus 58.3 degrees ohms. Okay, the same value 10 plus J into minus 16.1936 ohms is 19.032 at an angle of 58.3 degree ohms. Okay. So now that we found out Z bar and we already know V bar, let's find I bar. So I bar is equal to V bar by Z bar. V bar is 100 at 0 degrees divided by Z bar is 19.032 at minus 58.3 degrees. Okay. So this will be 100 by 19.032 and angles, division of angles means subtraction of angles. 0 degrees minus 58.3 degrees. 0 degrees minus 58.3 degrees. Okay, this will give us I bar is equal to 100 by 19.032 is 5.254. 5.254 at an angle 0 minus 2 minus plus 0 plus 58.3 degrees, 58.3 degrees amperes. Okay, this is the value of I. Unlike DC, where in case of DC we will get I is equal to 12 amperes or 5 amperes, just that it. Here I bar or I is AC value. So AC value must have an amplitude, a magnitude and an amplitude, a degree. Okay, so that's I bar. Okay, and this angle in I bar, that is 58.3 degrees, is the phase angle. Phase angle is positive in this case, so that means I or the current leads voltage by 58.3 degrees. Okay, so this is all of AC. We know, as we know, all of alternating current or a single phase AC is about finding this leading or lagging angle. Okay, so if voltage is 0 degrees and current is at 58.3 degrees, positive 58.3 degrees, so I leads V. Okay, so why does this happen? When in case of DC only there is only R. Okay, and we don't have any angles because R does not shift angles. Okay, only L and C shifts this angle, 0 degrees to some other degrees, and pure L shifts 90 degrees and pure C shifts 90 degrees, but in combination we will get some other value, 58.3 degrees. So all of single phase AC module is about finding this angle and using this to find power factor and power consumption. So in this case, phase angle is 58.3 degrees. Okay, once you know phase angle, power factor is simply cos phi, that is cos 58.3 degrees. Here you have to keep the calculator in degrees. What is the value? Power factor is 0.5255 leading. You have to not forget leading it. Even if the phase angle is in negative, you take cos phi as angle as positive when you are calculating power factor, and attach a lagging word. Okay, here if it is phase angle is negative, the current is lagging the voltage. Okay, so this is power factor. So finally, what is power consumed? Power consumed is VI cos phi. Okay, in this case, see there are no bars above the V and I. Okay, here there are bars above the I. So these are AC values. Here we only need to take the magnitude of the V and I. So what will that be? V is 100 and I is 5.254 and cos 5 is 0.5255. Okay, so what will that be? The answer is 276.1 watt. Power is 276.1 watt. Okay. So these are type of question you will get in the exam. They are very easy if you understand especially the second module, the single phase AC circuit and 3-phase circuit. There is a lot of need to understand the concepts. Even if you remember the formulas, Z is R plus J, XL minus XC, and XL is something like this, you can't solve this. You must have an understanding of what the phase angle is, what does the positive sign means, what does the leading and lagging means. Okay. See you in the next. If this video helped you and if you want to learn more, check out our full basic electrical course. The link is in the description. Also, like this video and share it with your classmates, and subscribe to the channel and press the bell icon to keep learning.